Hi students, today we are going to discuss a topic, namely which is easier, push or pull. So for that let us consider an object of mass m which is placed on a surface whose frictional coefficient is mu s. Okay, a force F is acting obliquely on the object, neither along the horizontal nor along the vertical. So the force F acting on the body is pushing the object towards the right side. So a static frictional force Fs is acting towards the left side. Now I will resolve this force F into two components. Since it makes an angle theta with the vertical direction, its vertical component will be F cos theta and the horizontal component will be F sin theta. And the weight of the object mg is acting in the downward direction. The normal force of reaction N push is acting in the upward direction. Now a free body diagram has to be drawn for the case of pushing a body. So you can see here, this is the mass m. Its weight is acting vertically downwards. Along the same direction, the component of the force F cos theta is also acting in the downward direction. Then F sin theta is acting towards the right side along the positive x-axis. And the frictional force, static force of friction is acting in the opposite direction, that is towards the left. This is the actual applied force F, which is making an angle theta with the vertical direction. Now in this free body diagram, you can very clearly understand that F sin theta and Fs, they will be equal and opposite. They will cancel each other. Now you see that N push acting upwards must be equal to the sum of the components mg plus F cos theta. Is it not? So this N push must be equal to what? This component mg plus F cos theta. Therefore, what should be the maximum value of the frictional force in this case? The maximum value of the static friction, that is Fs maximum, is equal to mu s times the normal reaction N push. Therefore, what is Fs maximum value here must be equal to mu s into mg plus F cos theta. Okay, this is very clearly visible from this free body diagram. Similarly, now let us go to the case of pulling a body with the same force F. So the applied force F is making an angle theta with respect to the y-axis, and it is split into two components. One is the vertical component, here is F cos theta, the horizontal component is F sin theta. Now mg is the weight of the body acting vertically downwards, and N pull is the normal force of reaction acting in the upward direction. Now this time the force is F is acting towards the left, therefore the frictional force Fs will be acting towards the right side. So the free body diagram is drawn for the mass m. So all the forces acting on this mass m are represented here. First, weight is vertically acting downwards, mg. Then Fs is acting towards the right, which is cancelled by F sin theta, which is acting on the left hand side. Now since F is making an angle theta of the vertical in the upward direction, so this component F cos theta and N pull, the normal reaction, these two will be added up to balance the weight. So in this case, N pull plus F cos theta. So here N pull plus F cos theta must be equal to mg. Therefore, what is N pull must be equal to mg minus F cos theta. Okay. Therefore, what is the maximum value of a static frictional force Fs maximum? This is equal to mu s into N pull, or Fs maximum is equal to mu s into mg minus F cos theta. So if you compare the frictional force in the two cases, what is friction actually? It is opposing force. So here the opposing force Fs maximum is mu s into mg plus F cos theta. Whereas in the case of pulling an object for the same given force, applied force, Fs maximum is mu s into mg minus of F cos theta. So here this F S maximum in the case of pushing is greater than Fs maximum in the case of pulling the object. So in which case friction is lesser, in that case only movement will take place in a much smoother way, isn't it? So comparing to these two cases, it is found that pulling a body is always easier than pushing the body with the same force. Now in most cases we will push along the horizontal direction or pull it along the horizontal direction where theta is equal to 0 degree. So in such a case, if you substitute theta is equal to 0 along the horizontal direction, if you apply a force, then cos 0 will be equal to 1. In that case also you see here for the pushing, the Fs maximum is equal to mu s into mg plus F into 1. And here in the case Fs maximum is equal to mu s into mg minus F into cos 0 is 1. Again the frictional force is comparatively lesser in the case of pulling an object. Hence we can conclude that pulling an object is always easier than pushing an object. I hope you must have understood well. Fine.